Three PLC counter instructions look almost identical on the rung. CTU, CTD, CTUD. They do completely different jobs. The wrong one creates a counter that runs, but counts the wrong thing, or stops counting entirely. This video walks the whole family. The shared structure, the behavior of each one, the real rung each counter belongs in, and the one mistake every beginner makes the first time. Every modern PLC counter follows the same shape defined by IEC 61131-3. There are several pins. CU increments the count on a rising edge of its input. CD decrements on a rising edge. Reset clears the count back to 0. LD loads a preset value into the current value. PV is the preset, the target the counter compares against. CV is the current value, the running count. Q is the output bit that goes true when the comparison condition fires. The three different counter instructions all use these same pins. The only difference is which pins are wired and how Q reacts. Learn the shape once, and you can read every counter rung in any vendor environment. The first counter is CTU, the count-up counter. It is the most common counter on a factory floor. Each rising edge on CU adds 1 to CV. When CV reaches PV, Q goes true. Q stays true even as CV continues counting past PV. To reset, fire reset, which clears CV back to 0 and drops Q. CTU answers the question, count events up to a target, then act. The classic uses are bottle counts on a packaging line, part counts on a press for batch tracking, event tallies for downtime reporting, cycle counts for predictive maintenance, anything that asks how many events have happened since the last reset. The second counter is CTD, the countdown counter. It works the opposite way. CV starts at PV, set by an initial LD pulse. Each rising edge on CD subtracts 1. When CV reaches 0, Q goes true. The pattern answers, count down from a known starting value until done. The classic uses are remaining items in a fixed batch, remaining parts before a tool changeover, remaining cycles before scheduled maintenance, remaining filled bottles before the labeller needs reloading. CTD is the countdown timer of the discrete world. Whatever started full now empties one event at a time, and the rung knows exactly when 0 is reached. The third counter is CTUD, the up-down counter. It has both CU and CD inputs. CV moves up or down as either input fires. Q goes true when CV reaches or exceeds PV. The pattern tracks net values. Vehicles in a parking lot, where each entry sensor increments and each exit sensor decrements. Units in a buffer between two machines, tracking how much work in process is queued. Items moving between 2 points on a conveyor where some go forward and some go back. CTUD is what you reach for when the count goes both directions. The simulator shows all three counter outputs visible at once on the same rung, so you can see exactly when each fires. Here is the most common beginner counter trap. The intended behavior is count parts per shift, then reset at end of shift. The beginner reaches for CTU, wires the part sensor to CU, and forgets to also wire a shift-in signal to reset. The counter runs all day and all night. CV grows past PV and keeps growing. Q is true the entire second half of the shift. The shift-in changeover runs, but nothing resets, and tomorrow's counts start from yesterday's number plus the new arrivals. The rung looks correct. The math is wrong. CTU is the right instruction. The missing piece is the reset wiring. Every CTU rung in production code needs a deliberate reset path. Otherwise, the counter is unbounded. Vendor differences to be aware of when moving between environments. The IEC standard defines outputs as Q and the current value as CV. Allen Bradley RS Logic's 500 and Studio 5000 use CTU.dn as the done bit. CTU.acc is the accumulated value. CTU.pre is the preset. The names differ. The behavior is identical. Mitsubishi GX Works historically used a coil-style counter where the counter coil acts as the CU pin and a separate contact reads the output. The mental model is the same. Just look up which pin or bit on which vendor maps to the IEC concept. Counters are not a place where vendors invent new behavior. The standard is shared. Run all three counters yourself at plcsimulationsoftware.com. The lessons on the free tier cover CTU, CTD, and CTUD step by step with each counter visualized live as the rung executes. You can watch CV tick up and down. Watch Q flip at the moment CV matches PV. Press reset and see CV clear instantly. Next video on this channel covers a complete Studio 5000 first program for a Rayall Allen Bradley project. Subscribe. There is a new video every Tuesday. See you in the next one.